apologies, I can't be there in person today, but the world is a bit crazy at the moment, so that's where we are. So I'm going to get some help just changing the slides as I'm in Zoom on my phone. I have my I can see it there now. Thank you very much. So for those who I haven't met, and I think I met most people there, my name is Paddy Mulvey. I work for ESB Networks in Ireland. So ESB is the single distribution system operator in the country of Ireland. And unlike the UK, where there's multiple DNOs, we're the single DSO. And within that, I work in networks telecoms. So what networks telecoms do is deliver the critical communications for the business itself. And obviously that goes back for a long way. And we also provide communications for the TSO. We've got one single TSO being airgrid in the Republic of Ireland. So we plan, design, and deploy support the telecommunications infrastructure for critical communications. And just a bit of perspective, there's about 2 million homes in Ireland that we provide electricity to, and obviously a wide range of industry and data centres. And there's about 5 gigawatts is the maximum capacity. So if we move on to the next slide, please. What I'm going to talk about today is the journey, really, the smart grid journey we've been on in ESB, where we've come from, where we're going to, and how we got there, really. So obviously, for any journey, we need to understand where we came from. So kind of the past, any utilities we're all familiar with, we've had kind of small numbers of communications, a small number of locations. We've had from key infrastructure. We've had communications that have been deployed. The issue with it has been scalability, really, going back in time. We've had a small number of locations with high spec mission critical communications. And that's kind of where we all started as utilities. So this is just a picture of where we are in the present in ESB networks. We've got microwave radio around the country. We've got our own multiplexer network. We have fiber, our own fiber pair available to us. We've got polling radio, the SCADA telemetry that a lot of entities have, and we've got satellite and third-party mobile networks. So we've a wide range of communications services available to us to meet all our needs. And I suppose the graphic on the right is really, and I'll come on to this on the next slide also, just identifies the issue that we tend to have. So just on the previous slide there. So I think we went on a slide too far. Yeah, so the graphic on the right here identifies the issue that a lot of us will be familiar with, really, that we've got really good visibility to 38 kV. So about 600 38 kV stations, and then a few 100 kV. And so it's a limited amount of locations. We've got really good visibility, but below that we have little or no visibility. And the issue being that there's a large volume of those 20 kV, 10 kV locations. The volume is large and it's spread all over the country, but there's not really a scalable mission critical solution that we had in the past. That's really where we've had our limitation. We've had mission critical communications at a very costly and non-scalable way. So if you go to the next slide, this identifies why telecoms is changing, why we're doing something different. And I suppose the electricity network is changing, and we can all appreciate that. COP26 very recently really highlighted one of the key areas, decarbonising the network and trying to be as energy efficient as we possibly can be for the environment. So that's one driver, but then we're integrating more renewables. There's going to be prosumers. There's Mark identified, there's going to be two-way flows of electricity. There's going to be more EVs. There's going to be electrification of heat. So the dynamics of the whole entire electricity network is changing. The way the electricity flows, the distribution, the usage, the patterns, the local usage in an area as well. So we can't have local substations getting overloaded, for example, with capacity. So there's a wide range of dynamics changing within the electricity network. So in order to accommodate that and to be able to deliver what needs to happen in the future, the telecom solutions need to also change. So visibility is, this graphic here, really what it shows is the system today and where we want to get to. And the key message really is visibility. So more pervasive visibility. So more understanding of what's happening lower in the network is really the key message I would take from this. And that includes the integration of renewables. So the top right graphic just really shows that ESB has a brighter future strategy for until 2030, and that's really the real key message is, we need to have a lot more communication solutions to deliver more services to support a brighter future. So, please, yeah. So we in ESB Networks understood that the telecom solutions we had weren't going to deliver on the future requirements. So we did a deep strategy dive effectively, and we identified what the as is situation was and the to be was going to be. So we understood there's a big gap between where we are and where we want to get to. So we identified a gap, and we looked at all the public, private, wired and wireless solutions available to us to meet our needs in the future. And we identified that the development of a private network was the only solution which is going to deliver on 5 key elements, which I'll mention just now in a moment. But this graphic here, what this is identifying really is what a lot of utilities will be familiar with, the dark blue being, the fiber, microwave radio, the core network, which we typically have as utilities. And then beyond that, a bit more into the access layer, the polling radio, fiber, microwave radio, which we're all familiar with. I suppose the point being there's third-party solutions beyond that. But this green area that's identified that's really a big volume of services, locations that are unserved and they don't have a solution available to it. And that's the gap that we're trying to provide a solution for. So the deep strategy dive proved that there needed to be a private network was the only way to deliver on this. So 5 key areas that was identified that this would help it with cost, the availability of the service, so we could tailor a mission critical network to deliver highly available services. That's what we as utility service provider has done to date. That's what we do well. So availability and designing a solution that it's going to be highly reliable, particularly when there's outages, when mobile networks and others go down. The life cycle of devices. So we were able to install CPEs and telecoms devices, which will be there and working indefinitely. So we're not at the behest of a third party who might change your offering. For example, 3G will be shut off next year, and then you have to scramble to change your 3G device to 4G and then 4G to 5G in time. So control of life cycle is another one. Coverage. Coverage is an important issue, and we have assets and devices we want to communicate with, which aren't always in the urban areas, which are typically covered by third-party networks. So tailored coverage, and then cybersecurity. We wanted to have a cybersecurity solution which we can rely on. Obviously, attacks are more frequent now as well, so we need to have a solution which we can design to our requirements and meet our needs. So the 5 key elements was costs, reliability, life cycle, coverage, and cybersecurity. So that's why a private network was seen as being the optimum solution for us. So on the next slide, please. Yeah, so this graphic is quite simple, but to enable a smart grid network, there's kind of 3 key that's what we identified. You need to have the finances available to you. You need to have the regulatory environment, and you need to have the technology environment to make anything a reality. And they're interdependent issues, I suppose. That's the key thing I'd like to try and identify. So what I mean by that is, with regards to the financial side of things, we had approval from our energy regulator in 2016. We got approval to start looking at developing a smart grid. And we made a submission and we understood why we needed to do this. We didn't know how we were going to do it at that stage, but we needed. So our 5-year period start in 2016 to 2020, similar to the UK, where Rio is, I believe, the price review period, but we have a PR period. So in 2016, we got approval to start the development of a smart grid. So because we got that financial backing, we were able to work with industry. So JRC, EUTC, 450 Alliance, numerous different vendors, academia. We were able to go out and engage with a lot of different entities to understand what was out there to enable a smart grid. And there was radio spectrum which was going to be relinquished in Ireland because it wasn't used by a previous entity. So and that was in the 410 megahertz range. So because of all this engagement, we were able to understand that there was technology available and there was spectrum becoming available. So Comreg took it seriously because we had financial backing from the CRU. So that enabled us, and I'll show on the timeline later, that because we had the finances and the regulatory environment, that spectrum was becoming available, that enabled vendors to be interested and technology providers to be interested in looking at providing a solution for us, because not only did we have the financial backing, we had the regulatory environment and the prospect of radio spectrum becoming available for us. So that enabled us to carry out technology trials, which enabled the regulator to make a decision to release the spectrum. So when these things work hand in hand, it enables you to achieve something. So if you go to the next slide, please. Yeah, so this graphic is just looking at technology trials we carried out. So my timeline now in a moment will identify how this kind of played out, but we did trials of LTE in 410 megahertz in 2019, quite rigorous and detailed testing. So we used one of our ESB hill sites that we have, our own backhaul infrastructure, our own network that's available to us, and we connected up to test RTU devices, DA devices, simulators, etc., to really bombard and test the network as much as we could. On the right hand side here, so that information that we learned from that technology trial fed into a coverage analysis. So JRC were our experts that gave us advice and gave us a lot of help with that. So we were able to feed in the information from the trials into a radio network planning exercise, which fed into a business plan, which enabled us to develop our strategy for this. So like the trials gave us numerous different things like throughput, helped us understand the coverage we could achieve, the scalability, the cybersecurity offerings that are available, the form factor of CPEs, how a deployment would look. There's going to be a lot of learning from that. So if you go to the next slide, please. This is the next slide. Will just show you that this on the left hand side is quite busy, but people can take it offline and look. We can see the architecture of the technology trial, the different CPEs, the locations, and how it all put together. At the top right and the bottom right there are just throughput simulations that we had and latency and bit error rates, etc., that we achieved. There's quite a lot of information that was learned from that. So it was very important that we did that trial to give us the comfort that the 410 megahertz in LTE was something that we needed to work towards. So on the next slide, please. So this timeline, I think, is helpful to kind of identify the process that took place for us and how it helped us to get where we are, and I'll identify where we're going to get to in the near future. So, as I mentioned, in 2016, we made a submission to the CRU, the energy regulator in Ireland, to get access to funding for a smart grid network. And again, we weren't aware at that point in time what technology we'd use or what spectrum, but if we didn't have the approval, it would make it difficult in the 2016 to 2020 period to make any progress. So between Q2 2017 and Q3 2018, engaged with EUTC, JRC, Seagray, Comreg, 450 Alliance, and a wide range of equipment vendors. How this started was Comreg had a spectrum strategy in 2018, early 2018, for the 2018 to 2020 period, and we ourselves in ESB made submission, but equally a lot of the partners we were working with made submissions, and I think 9 of the 11 submissions to Comreg spectrum strategy were in favor of releasing the spectrum. So like the main input into Comreg spectrum strategy was in relation to this radio spectrum. So that encouraged Comreg to release it. So in Q3 2018, a key thing that Comreg decided on was that they were going to release spectrum specifically for smart grid. So that was a huge win, a very positive. I think Comreg recognised the importance of smart grid. The rationale for that was that Comreg seen that smart grid was an important thing that needed to be delivered, but equally Comreg recognised third parties don't have networks which can provide on that. License exempt spectrum wouldn't give us what we need. So they understood that the technology wasn't available in other networks and the spectrum wasn't currently available. So that's why Comreg decided to make spectrum specifically available for smart grid. So I'll come on to it in a minute, like who else can use the network that we're going to be developing. So because of this encouragement, because Comreg's decision to release spectrum for smart grid, in 2019 we did technology trials, LTE technology trials in one of our transmission sites, and that's a key thing for utility. We've got our own hill sites that we've got access to. We've got our backup power available. We have space available in cabins. We've got a operation center who can manage our network. So there's a lot of benefits for us to be able to deliver on this. And feeding in from that technology trial, JRC did a radio coverage planning exercise, and then in Q3 2019, we were able to develop a strategy and business case which was submitted and approved to our board. So I don't want to go into specifics of numbers that are in our approval, but it's definitely a good bit north of project. So in October 2019, we participated in Comreg's award process. So if we can go to the next slide, please. Yeah, so in November 2019, we were successful in the award process. So we got 2x4 megahertz of spectrum in the 410 to 414, 420, 424 megahertz range. So based on that, then we did some market warming exercise, engaged with vendors, equipment vendors, integrators, service providers to understand the offerings early 2020, and a team was set up internally to gather our requirements as a business, technical requirements, volumes, timelines, etc. We began our procurement exercise in Q4 2020, so PQQ process, shortlisted entities. We issued a RFT, request for tender documents, and we've received our responses from shortlisted entities. So we're going to be finishing the tendering exercise in Q1 2022. And the reason why that might look a little longer than usual is because we have included a verification stage. So the highest scoring tenderer from the evaluation of the tenders will be required to conduct a verification stage. And that means installing a mini core, installing 3 ORUs at a site, providing 10 CPEs for testing, so we can actually see that the end-to-end solution works correctly and delivers what it needs to do. And then once that's achieved, the contract will be issued. And then on the top right, it shows the timelines then. So from Q3 2022, we see the network rollout beginning in Q3 2022. We have approximately 90 high sites initially and 15 to 20,000 CPEs, which will be in the rollout plan. So that's our ambition to deploy over a 3-year period. Albeit, if requirements come in and if there's more scope and requirements from the business to deploy more, we can do so. So then that's just onto the next slide then. And I know this has been a whistle-stop tour, but that's what really wanted to identify very briefly there was that, we've come a long way in our journey. We had a lot of obstacles, but what we've done and what we've put together is going to enable us to deliver on the smart grid of the future and to be able to enable the electricity grid of the future, because things are changing dramatically and our telecom solutions need to stand up for that. So that's all I just wanted to say today. So thank you very much.
Yeah, keeping to schedule as well, nicely. Thank you very much. We do actually have about 5 minutes before the next presentation. Has anybody got any questions either online or in the room? Bob is poised with his microphone. No? I think what's telling there is Paddy's really demonstrated the scale of the problem or the issue, the number of sites that we've got out there. I'll talk to you in a minute. But also he's looked at how he can resolve it and really brought the regulator on the journey with them, right from the initial conception. This is what we want to do, this is how we're going to prove it'll work. And this is kind of where sort of Great Britain, England, Scotland and Wales are at the moment as well. We're doing a lot of canvassing, a lot of policy pushing to try and bring Ofcom, Ofgem, and as well as the government units along as well. So thank you very much for that, Paddy. Julian's poised. Go for it.
Thanks very much, Mark. Paddy, hi, good to see you again, even over a video link. So yeah, thanks for an excellent presentation. Interesting, I think, as you say, the timeline to look at that, and reflecting on something that Ian Smith mentioned this morning or in the earlier session about having to have our ducks in a row at the point that we have this very, very complex and difficult challenge of getting spectrum access, but then at the point that you get access to the spectrum, you've got a whole set of new challenges facing you that you maybe didn't anticipate earlier on. So it's just a couple of things I was going to ask you about. One was about whether you've looked or considered some of these distributed core technologies now rather than a hard and fast hardware core, and also if you've got any comments on the area around mobile network codes and numbering, because we recognise that these are things that come hot on the heels of achieving spectrum access. So I don't know if you have any comments on that, Paddy.
Yeah, so with the core infrastructure, I mean, we're guided by our IT security elements. So physical hardware is where we're kind of looking at initially. With mobile network codes, we don't see that being an issue in the Republic of Ireland because we've engaged with Comreg on this multiple times. So for our test network that we had in 2019, we were issued a test MNC, and we've been in discussions with Comreg on this, and they see our network requiring an MNC, so there's no issue regarding to access to an MNC, a dedicated MNC and numbers for this. I think that owes to the fact that Comreg have always been quite conservative with regards to releasing MNCs. So therefore, they haven't. Two things: they haven't had an issue with regards to running out of MNCs is one thing, but they haven't set a precedent if they haven't given away MNCs cheaply, and because of that, they're not withheld to a precedent-based kind of future issuing, so that they kind of see why our network requires MNC, and that's the way they see it. Simple as that. So they're going to issue an MNC. I know in other jurisdictions, MNCs might have been distributed far more liberally, and that's created its own problems. And then anyone that's developing something along these lines has probably been caught up in that whole the whole issue that they've created, I suppose.
Okay, thanks for the answer, Paddy. Cheers.
Cheers.
Quick,
yeah. Paddy, hi, it's Peter Couch. Thanks for your presentation. Just a quick question. I wonder what thought you've put to the extent to which the smart grid capability that you're rolling out will enhance resilience within the energy supply network, and how that has been factored into your plans?
Yes, absolutely. Well, I suppose we can all appreciate that when currently now we've got a solution which is dependent on mobile networks, our distribution automation. So our reclose, our switches, some of our key electrical assets are reliant on mobile networks. So when an electrical outage happens, that network goes down. So we're caught in a circular problem where we need to get the power on to get the devices that we need to get the power on back up. So it's a big problem. So that's why the network we're deploying now, we're going to have 24-hour backup at each transmission site, and it's just going to give us much more reliability, and it's just going to help us. You're right in identifying it, Peter. Like it's going to give us much more of a benefit, and much speedier. It's going to give us less outages, and it's going to give us speedier response times, really. And then there's the additional benefit of safety. We're not going to be sending people out in the dark with no information about where the faults are or what the fault is. So there's kind of a wide range of safety and speed bonuses when it comes to deploying this network with regards to faults and outages.
Paddy, hi, Ian Smith. Again, thanks for today. Two quick questions for you. One is from an operational perspective. Some of the, so WPD have done its innovation trials on LT in the southwest of England. We have focused on data, voice, and video. So I'm curious, in terms of the use cases that you've currently got within scope. And picking up on some of the conversations with earlier guest speakers and questions that we haven't had a chance to answer, but who is ultimately paying for the project?
Yeah. So two things. I don't use Zoom very much, so I went a bit digital on me there. So I think the first question was about data and voice. So yes, we are deploying a data primary network. That's our network initially is going to be for data, purely data. But in our tendering process, we have identified, and we do understand that there is I don't know if I've dropped out. Sorry, I think it might be back there now. I think it might have dropped out. So yes, sorry, we are planning for a mobile solution in the future. So we have identified in our RFT that we do have plans to have mobility and voice communications a feature of this network. It's not going to initially be in the first tranche, the first rollout, but we are preparing, and we have prepared for that. So that's something that we definitely do want to do. For example, we've got about 600 devices on Tetra at the moment, and Tetra, as we appreciate, isn't cheap. So we would be mindful and looking to transition them users over to a voice solution using our own network if and when that was suitable. The second question, sorry, was regarding, I missed that second question. Who's paying for it? Sorry, who is paying for it? Well, yeah, sorry. I suppose you can ask, we as ESB networks are paying for it. We are, but you can ask, where do ESB networks get their money from? Well, we get our money from the charges effectively with for operating the distribution network. So you could argue that the end customer is paying for it, but our business case looked at it, and this network will save money compared to the alternatives. One thing that we found difficult was there's a lot of financial benefits, and we were able to compare if we did it a private network as opposed to using public networks. we could compare them costs, and this is more favorable over the timeline. There's a lot of intangible costs which we couldn't factor in, but they would only add to the business case. So the reality is that what we are deploying is going to save money effectively compared to the alternative, but the intangible benefits are also considerable.
Brilliant. Okay, we'll move on to the next presentation now. Thank you very much, Paddy. That was really good. That was really educational for me as well. Thank you.